Hi, Mr. Hanna here. Welcome to the next chapter, which is on combinatorics. Now, combinatorics is just a fancy word that means sort of counting methods, different ways of counting possibilities. And it's very important, especially for probability, because as you remember, the probability of some event A is given by the number of elements in that event, divided by the number of possibilities in the sample space. So a really important thing is actually being able to find this number. How many possible things are there? And that's what combinatorics is all about. It's about different ways of counting things. So a typical example might be, say, a number plate. So in a typical sort of Australian number plate, we have 3 letters, let's just say A, B, C, and 3 numbers, 1, 2, 3, or something like that. And the question might be, how many possible number plates are there that have this arrangement of letters and numbers? And the way you would sort of think about it is, well, there's 26 possibilities that could go here. There's another 26 that could go there. So that's a times 26. There's another 26 that could go here, so another times 26. There's 10 digits from 0 to 9, so that's a times 10. And times 10 again, and then times 10 again for that. And if you put all those numbers into a calculator, and you'd come out with the answer of how many possible number plates there were. And you could obviously then calculate a probability from that. So there's a very brief introduction to a little example of something to do with combinatorics. And lots of other things will work like this, like identification numbers and things like that will work on the same sort of principles. Now this video is the first video. It's all about permutations. Now permutation is a bit of a word when we're talking about arrangements. Arrangements when order is important. When the order is important. And you can think of this as kind of a bit like our number plate example from earlier, because if you had a number plate that was ABC 1, 2, 3, that is totally different from BAC 1, 2, 3. It contains the same letters here, but the order is different, so the order is important here. One other thing about permutations, though, is typically we have you can't have repeating things. So here this is just a combination, but if you have a permutation, you generally don't include like A, B as a possible number because you've got 2 A's here. So usually when we're talking permutations, we're talking about no repeats happening is usually what we're talking about. So order is important and no repeats. No repeats. That's what we're usually talking about when we're talking about permutations. Okay, so let's have a think about a possible example. So let's say that you've got a bookshelf. You've got 6 books. You've got the red book. You've got the blue book. You've got the green book. The yellow book. The purple book. 1, 2, 3, 4, 5. And you've also got the run out of colours, so I'm going to say the topaz book. Why not? Okay, so there are your 6 books, and you want to know how many different ways can you arrange them on your shelf. Well, obviously there's only 6 places on your shelf. 1, 2, 3, 4, 5, 6 places on your shelf. And something has to go in this first position. And there's 6 options, so obviously there's 6 different things you could possibly put there. Now in your second shelf, the second position, because you've put one thing there, you can only choose 5 from 5 other things to put them in the next position. And then you can only choose from the remaining 4 things to put them here, and the remaining 3 things, put them there. And then there's only 2 things left, so you have to put one of those there, and then you've only got 1 thing left, so it definitely has to go there. So if you multiply these all together, then you'll get the number of different ways you can arrange those 6 books. And you can see there's quite a lot. 6 5s, that's 30. 30 times 4, that is 120, times 3, that's 360, times that by 2, that is 720. So 720 ways to arrange 6 books on a shelf. It's quite a lot of different options, probably more than you expect, perhaps. So there you go. That's basically that's the basic gist of the permutations. There is just arranging things when order is important and having no repeats happening. And you can see that is a bit different to when repeats are happening. So repeats in this particular case would mean you have, you have 6 different books, but you have lots of copies of each one. In which case you could have, more options. You could have the same book in each position, for example. Okay, so that's a simple permutations sort of example. It's really pretty easy in my opinion. So there is, however, a more clever way to represent this sort of thing that your calculator uses to do these calculations a bit more quickly. And that's called the factorial. So this thing here, 6 times 5 times 4 times 3 times 2 times 1, we call that 6 factorial. And the symbol is this exclamation point. So 6 factorial is just 6 times 5 times 4 times 3 times 2 times 1. There we go. So let's write some other factorials down so you get the idea. Factorials. Okay, so let's start with 2. 2 factorial is just 2 times 1. So it obviously equals 2. 3 factorial is 3 times 2 times 1. So that is 6. 4 factorial is 4 times 3 times 2 times 1, which is going to be 24. And, I think you're probably getting the pattern, so it could be on and on and on. Now, a few other things. 1 factorial is just 1. So there you go, pretty easy. Now, do you notice that 4 factorial is just, it's the same as this 3 factorial, but with a times 4. So 4 factorial is actually just 4 times 3 factorial. And 3 factorial is, well, that was just 3 times 2 factorial. Or, in using symbols, I could say that some number n factorial is that same number times n minus 1, 1 less than it, factorial. So, for example, if n is 5, then it would be 5 goes there, 5 times, now 5 take away 1 is 4, factorial. And that fits the same pattern. This is really useful if you wanted to look at, let's look at 1 factorial. 1 factorial using this n business. So 1 factorial is 1 times, remember here n is 1, so that's 1 minus 1 factorial. Or in other words, 1 factorial, actually 1 factorial we know it's over here, it's 1. So 1 factorial is 1, and it equals 1 times 1 minus 1 is 0 factorial. But this is interesting. 1 equals 1 times 0 factorial. In other words, we must have 0 factorial being equal to 1. Otherwise, this will not work. So 0 is a key point. 0 factorial is actually equal to 1 as well. It's not equal to 0, it's equal to 1. So there you go, there are factorials for you. And there's some cool things you can sort of do with factorials. They kind of cancel each other out a bit, which is sort of nice. Let me show you what I mean. Like, suppose you had a question like this. 8 factorial divided by 5 factorial. Well, 8 factorial, that's 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. over 5 factorial, that's 5 times 4 times 3 times 2 times 1. And you'll notice we can do a whole heap of cancelling out. 5's cancel, the 4's cancel, the 3's they cancel, 2's cancel, and 1's cancel, leaving us just with 8 times 7 times 6. So there we go, that's all we're left with. If you really want to, you can come up with a rule and say that n factorial divided by r factorial is equal to... Oh, actually, no, this is silly. Ignore that. Okay, there you go. There's a little handy thing you can do with factorials to cancel them out. Instead of just evaluating these two, you can cancel out. Makes your job a lot easier. Okay. Earlier, we talked about this example with the books, where there were 6 books and there were 6 positions that you could put those books into. But what if you actually had, you still had your 6 books, but you only had 3 spots on your shelf. 3 spots on the shelf. And how many ways could you possibly arrange those books? Well, here are our 3 spots on the shelf. In the first spot, you've got 6 books to choose from, so you could have any of those 6. In the second spot, now you've only got 5 books to choose from. And in the third spot, you've now got 4 books to choose from. So there you go. Your answer is just going to be 6 times 5 times 4. And whatever the answer to that is, we'll give you the answer. So notice the link between these 2 examples. Okay. Okay, let me show you the link by doing this example in this sort of way. Okay, imagine if instead of 6 books, there were actually, let's do it again, but with 8 books. Imagine we had 8 books and 3 spots. Then it would be 8 times 7 times 6. Sorry for the messiness here. 8 times 7 times 6. Now, hopefully you notice that that's the exact answer we had here, 8 times 7 times 6. So somehow, if we have 8 books and 3 spots on the shelf, that gives us 8 times 7 times 6. So somehow that answer is 8 factorial on 5 factorial. Now, some of you will hopefully notice that, so here we've got 8 and 3, but here we've got 8 and 5. So to get from these numbers to these numbers, it's just 5 is actually 8 take away 3, which is the number of spots we had. So it's kind of like this, 8 factorial over 8 minus 3 factorial. These are the same thing. Okay, so this is a bit of a permutations formula. Okay, so we say that, let me write this down kind of formally, and then we'll do an example or two. Okay. Let's say if we arrange n objects into r positions, the number of ways we can do this, the number of ways we can do this, or permutations, is given by n factorial over n minus r factorial. Okay, that's what we've just seen. Okay, and we write this written as n, p for permutations, r for short. Okay, So we use this sort of symbol, NPR, for this permutations formula. So that's basically all you need to know about permutations. Now let's do a couple of very quick examples. All right, let's suppose we have a car. Let's make this example 1. Car race with 10 cars. How many ways can we award first, second, and third? Okay, so here in this example we have n is 10 because there's 10. Our number of objects is 10 cars, and our r is 3 because we have 3 positions. They could be first, second, and third. So we're doing 10p3, and using our formula, that is 10 factorial over 10 minus 3 factorial, which is the same as 10 factorial over 7 factorial, which is 10 times 9 times 8. 10 times 9 times 8. 10, which is 10 times 8 nines is 72. So that must be 720. Different ways that those can be arranged. Okay, fairly easy one. Let's do a couple of slightly harder ones just to get your mind fully around it. By the way, all the content's finished, so if you're feeling really confident, you can just do some exercises. But let's do a couple of extra examples to show you some trickier things. Okay, suppose we have a question like this. How many numbers greater than 1000 can be formed from using the digits 4, 5, 6, 7, 8, 9. When each digit is digit is used no more than once. Okay, how many numbers greater than 1000 can be formed from using those digits when each digit is used no more than once? So it could be used 0 times, or it could be used 1 time. So let's think carefully about this. The smallest number we could make out of all these digits, the very smallest one is, that's still bigger than 1000. The smallest one that's bigger than 1000 is 4, 5, 6, 7. That's the smallest one we could make. And you see that it has 1, 2, 3, 4 digits in it. So for this particular one, we've got 1, 2, 3, 4, 5, 6 as our number of objects, so n equals 6. And we have 1, 2, 3, 4 places, so r is 4. So that is 6p4. But we could also make a 5-digit number. What if we had 6, 7, 8? A 5-digit number is also bigger than 1000. So that one would be plus. Now we've still got only 6 digits, but we have 5 places to put those in. But then hang on, we could also have a 6-digit number, which is bigger than 1000. So that could be 6p6. And that's all of our possibilities of different numbers that will give us bigger than 1000. So 6p4 is 6 factorial over 6 minus 4 factorial plus 6 factorial over 6 minus 5 factorial plus 6 factorial over 6 minus 6 factorial, which is 6 factorial over 2 factorial plus 6 factorial over just the number, or 1 factorial, plus 6 factorial over 0 factorial. So that gives us, for this one here, we have a 6 times 5 times 4 times 3, plus, this is just 6 factorial, plus, this is also just 6 factorial, because 0 factorial is equal to 1. So here I'd just put all that into my calculator because that's the easiest way. By the way, factorial, let's find a factorial for you. So 6 factorial, just so you know, there's the 6. And then here, this button over here gives you the factorial symbol. There you go, 720 is 6 factorial, just so you know. Also, if you want to be really lazy, you can go into menu. We're looking at probability here, and permutations are what we're looking at. So here's the NPR. So if you want to do 6P4, you do just 6 first, and then comma 4. So that's saying the 6 is the N, and the 4 is the R. And there you go, 360. So you could use that method as well to find your final answer. I think that will do. There are some more examples, but check those out in the book or ask me for help if you get stuck. All the best, and see you later.